Hey, boys and girls. Okay, so we went over the water cycle yesterday. I just drew it for you real quick. Now we got to understand why these happen. Okay, so that's going to be the hardest part. It's kind of like the reason as to why these things go through the changes that they do. All right, first thing we're going to talk about first is something that you cannot forget. It is vital, and your heart is vital. Your brain is vital to you living and being able to respond to people and to think. Your blood's vital. This thing is something you've got to know this the whole time during we talk about weather, okay? And that's going to be hot air and that's going to be cold air. And they have a couple of characteristics that you can't forget, okay? And it's going to be really important for you to know this so that you understand evaporation and condensation. So hot air has a couple of characteristics, okay? Well, obviously, it's warm to hot, okay? And we can certainly feel that this summer. There's also something else about hot. And hot air is really, really light, okay? And I mean in weight. All right. So when air gets hot, since it's really, really light, it wants to go upward, okay? And that's really important when we start talking about the water cycle because this hot vapor, this warm vapor we're going to talk about today, wants to go upward rather than down. Okay, so cold air is obviously cold, and the thing about cold air is that it wants to sink. And you want to know why? Because it's the opposite of hot air. It is extremely heavy. Well, I wouldn't say extremely heavy, but it's heavier than hot air. So cold air wants to dunk down. Now, there's something you got to remember about hot and cold air. This is like a cat and a dog that do not like one another at all. They do not mix well. And when these guys mix up, that's when you have these thunderstorms and these massive tornadoes and this very, very fierce weather is when hot and cold air begin to combine together, okay? So this is something you cannot forget. Hot air is light, it wants to go up or rise. Cold air is heavy and it wants to dunk underneath the hot air, okay? That's just something you're gonna have to remember for science. So let's talk about evaporation. Now, boys and girls, none of us were here at the beginning of time, as we all know. The earth was made 4 billion years ago, or just formed 4 billion years ago. I don't really know how it happened. I don't think anybody does. No videotapes of it. So I don't know if there was rain already on earth, or the rain had to fall, run off, and then we could go with the first step. I always start the first step with evaporation. That's how I'm going to kind of teach it to you. I don't think there is a first step, but I think this is probably the one that's the most paramount in starting. You're talking about water being pulled from the Earth's surface. Now, evaporation, like we talked about yesterday, is a vapor, okay? And that word is right there. You can't see vapor, okay? Vapor is invisible. So you cannot see evaporation happening, all right? Now, this is what I'm going to talk about real quickly, and you don't have to necessarily remember this that well until later in science, but I'm going to tell you right now that there are two kinds of changes in science that we're going to talk about this year. There is a physical change and there is a chemical change. Now, physical change could be something as easy as me ripping a piece of paper, okay? I've changed it physically. If I wanted to, I could put the piece of paper back together and tape it, and I would still have a piece of paper. I changed the paper physically. Now, if I did a chemical change, that means that I would take that piece of paper and burn it, and then I would have nothing but ashes left. Could I ever get paper again from those ashes? No. I chemically altered that paper. Okay, so when we talk about the water cycle, we're going to talk about physical changes. Because what are we basically focusing on when we talk about the water cycle? We're talking about water, my friend. And water can go through changes, okay? Think about it. You ever had a cup of ice and you let it sit out for too long? What did it change into? Well, it changed into a liquid. If you left it outside for a little while, it would change into a vapor and go back up into the sky and fall as liquid again. So it's physically changing. You're not getting rid of the water, you're just changing the way it looks, okay? So with evaporation, you're gonna deal with a physical change, okay? You're talking about water changing from a liquid into a vapor, okay? So, what's the number one piece of the puzzle we're missing? What starts all of this, okay? It's gonna be this guy right here, the sun. Let me make sure you can see that before I continue. Okay, cool, you can. It's the sun, okay? So the sun beats down on water, turns it from a liquid into a vapor. And this vapor is invisible. And not only is the vapor invisible, but what has the sun done to the water? It has made the water hot. And this hot water turns into a vapor, and what does it want to do? It wants to go upward, all right? Now, that's easy enough. There are two ways in which water can be evaporated from Earth's surface, and both of them are because of the sun, okay? Either the sun can do it, heat the water, turn it into a vapor, and let it rise up. What else is a huge force in nature that knocks all our trees down during hurricanes? Wind. Wind can pick up water as well and throw the water into the atmosphere, and it can go through the process of the water cycle. Okay, so let's go over that one more time. All right, the sun starts the water cycle. We couldn't do much without the sun. It gives us heat, gives us light, gives us energy, lets us have fresh water. So the sun starts it all. The sun beats down on water, and it turns the water from a liquid into a vapor. Okay, you can't see this vapor. You can't reach out and touch it and get your hand wet. Turns it into a vapor. This is a physical change. You're changing water from a liquid into a vapor. It's still water. It's just changed its states, okay? Now, when this liquid vapor gets warm, what does it want to do? It wants to rise. It wants to go up into the air. And when it starts to go up in the air, it starts to meet cold air. And we're going to talk about condensation tomorrow. And that's going to be another physical change. And remember, the two ways in which water can evaporate are the sun and the wind. Okay? Let's go over hot air and cold air one more time. Hot air is very, very light, and light things want to go upward, just like right here. Okay? The sun beating down on the water, turn it into a vapor, and all it wants to do is rise. Okay? It's not cold, it's not going to dunk down. And cold air is heavier. And cold air wants to dive underneath hot air. Okay, so we're not dealing with cold air when we're talking about the water cycle just yet. That'll be tomorrow when we talk about condensation, which is going to be kind of confusing because this right here kind of gets tested. And we'll talk about that tomorrow. You're going to be like, whoa, I thought you told us yesterday cold air sank. And it does, but there are kind of rules about it, and we'll talk about it tomorrow. So just remember this about evaporation. I don't expect you to be a wizard on this today. This is going to take a couple of days to learn, and so is condensation. Evaporation, condensation are the two toughest parts to learn. After that, it's pretty easy, you know? So we got to make sure we get this down. I got 5 questions for you. Make sure you get them done. If you do not know the answers, go back to the video and we'll look through the video again. And it should tell you the answers. I'm not going to give you anything that I did not go over, okay? Have a great day.